So good afternoon. Hope you had a good lunch. Everyone's awake. And we are about to start a panel on finance, so how to finance. The focus of this first of two panels is on how to finance research, tool development, and early exploration, and using public money. So the format for the next 45 minutes, I'll be moderating. So I am Alexis Templeton. I'm from the University of Colorado. I'm also here with the startup company Eden Geopower that's based in Boston, Massachusetts. I'm only serving in the moderator role, as these members of the panel will speak with you today. At first, we'll have a 15-minute talk. It's a keynote talk for this session, and you can ask questions after that talk, but we will then move to our other three panelists to also introduce themselves and some of their perspectives, and then we'll open it to the floor for more questions for our entire panel as well. So with that, we welcome you. And thank you.
Hello, good afternoon, everyone. Did not pick up the slide. Okay. Hello, good afternoon, everyone. My name is Yashi Mathur, and I'm a final year PhD candidate at Stanford University. And today I'm going to talk about the techno-economic analysis of natural and stimulated geological hydrogen. First of all, I would like to thank my co-authors for contributing into this work, Yalchin and Henry, and my advisor, Tapan, for advising us through this work, and Stanford Natural Gas Initiative that supports the research that I do. So, $1 million question, what is the price of producing natural and stimulated hydrogen? So there are a lot of numbers that float around, and different media houses present different numbers. So the motivation here was to slice and dice what goes into modeling, what goes into the cost of hydrogen, and most importantly, what are the drivers, what are the important drivers over here. So last year at HNAT, Doug Wicks presented which is the DOE targets for cost and environmental impacts of hydrogen, and where they said that the hydrogen cost at the wellhead should be less than $1 a kg, and a hydrogen GHG from production should be less than 45 cents kg CO2 equivalent per kg of hydrogen produced. And then there are certain thresholds for deposit potential and production. So going ahead, when we modeled this, the cost that we got for geologic hydrogen was 54 cents per kg, and for stimulated hydrogen to be 92 cents per kg. And that is, of course, less than what we see for low-carbon hydrogen. And for green hydrogen, the cost to produce green hydrogen is $8, $5 to $8 per kg, as per the IEA report. So this is the final result, but how did we arrive at this result? What are the parameters that we took into consideration? So to start off that, first, I'll just briefly talk about the envisioned geologic hydrogen value chain. So of course, it will be a multifaceted value chain like any other subsurface resource, such as oil and gas or geothermal. And the upstream part, I don't need to go through it. I think most people are expert in upstream over here. And the midstream part, we do not consider the hydrogen transportation costs over here, since the geologic hydrogen industry is still taking its baby steps, and we do not know how is it going to get transported. Of course, it will be very use case dependent, and we might have to truck it or transport it via pipes wherever pipes are available, or convert it into some other molecule such as ammonia, depending on the volume of hydrogen that we'll get or where the deposit is located. And finally, the downstream part. So hydrogen is sometimes also referred to as the Swiss Army knife of decarbonization, because it has applications in so many different kinds of industries, ranging from industrial feedstock to transportation, industrial and residential heating, as well as a fuel gas to industry. And the low cost of hydrogen can also unlock various new use cases apart from the existing use cases as well. So starting off with the upstream capital expenditure, we modeled certain costs, and just to re-emphasize that all of these costs are valid for United States. And we take certain costs for test drilling, and then we take certain costs for acquiring acreage as per the US Bureau of Land Management. And the drilling and completion costs that we take for geologic hydrogen well is $4 million. And for stimulated hydrogen, we take $6.7 million. And these are all geothermal benchmarks. For operating expenditure, we do not know of geologic hydrogen. There is not enough data available for modeling the operating expenditures. So over here, we take a wellhead pressure of gas of 7 bars, inspired from the Mali project, where they say that the wellhead pressure is 4 to 5 bars. And then we take a gas composition where the hydrogen concentration is 75% in the base case. And based on the literature that is available from different regions throughout the world, we take a specific composition for all the other gases that can co-occur with hydrogen, such as nitrogen, methane, carbon dioxide, and water. And we have modeled this process in Aspen Plus process simulation. And first of all, as and when this gas composition exits the wellhead, it needs to, the liquid water needs to get removed because it will corrode the downstream equipments. And then similarly, we remove the gaseous water, and then the hydrogen is purified from other impurities such as CH4 and CO2. And finally, there is amine regeneration. So this process is inspired from natural gas that we have replicated here for geologic hydrogen. And finally, the product that we have considered in the base case is hydrogen at a pressure of 30 bars with a 99% purity. Now, this will also be very use case dependent. For example, if we were to feed this hydrogen to a fuel cell, we would want a purity of, let's say, 99.9% of hydrogen. So all of this is very use case dependent, but this is the base case that we have taken. And then for stimulated geologic hydrogen, on top of the operating expenditures that we showed earlier, there would be additional expenditures in terms of water injection. So as per the literature, stimulating geological hydrogen is agnostic to the water that we inject into these wells. So the water that we might use is whatever is available and whatever is cheapest. And then we'll have some sort of catalyst injection. So various things have shown to enhance the production of hydrogen in the subsurface. And these are some of the catalysts that have been mentioned in the literature to enhance the hydrogen production. And we have taken those concentrations that are mentioned in literature. Including all of this, these are the base case parameters that we have taken. A lot of it is inspired by oil and gas, of course, well lifetime of 20 years and re-stimulation of 5 years, because some of the literature has also shown that stimulating or enhancing these reactions sometimes precipitates some solids. So there might be some sort of re-stimulation involved, and then annual operation days of 300 and a base case of 75% purity. And the most important factor, the production flow rate from the wells. So we have taken analogous to a medium case for natural gas wells, that is 200 kg hydrogen per hour. And then we define two things over here. First is the serpentinization efficiency, which is the production rate of hydrogen divided by the maximum production of hydrogen that can be stimulated from peridotite rocks. So in literature, people have made all sorts of measurements, and maximum we can generate 4 kg of hydrogen by stimulating 1 meter cube of peridotite rocks. So that's the serpentinization efficiency, and water containment is a standard definition from oil and gas. So based on all of this analysis, this is how we come up with these two numbers. And these are the stated assumptions that all of these costs are for United States specifically. And certain costs we have not taken into consideration because this is a very preliminary study and we do not have enough controls on all of the other costs. So we have not modeled them, but in future, as and when more data is available, we can of course include that. So apart from the dollar numbers, what is more important is what drives the economics over here. So to understand that, we do some sort of sensitivity analysis. So this is the tornado type plot, where the middle numbers are the base case that we take in our study, and on the x-axis you can see the cost, and the high and low case numbers are what is physically possible or what we have encountered in the literature so far. So for hydrogen concentration, we take a case from 85% to 35%. We see that in the sensitivity analysis, the most important parameters are hydrogen concentration from the well and the well flow rate that we are getting. And the drilling cost is the least important as per our analysis, because the capex is amortized for the entire life cycle of the well. So this is for natural hydrogen, and for stimulated hydrogen we have additional parameters, but here again the most important factor is the flow rate from the well and hydrogen concentration, followed by the delivery pressure. So increasing, further compressing the hydrogen will increase the costs, as also has been seen in natural gas processing as well. The other factors over here is restimulation efficiency, restimulation frequency, how often are we stimulating these wells. That increases the cost of producing hydrogen. So since these two things, the flow rate and the hydrogen purity are most important, so we tried to delve deeper into what does it actually look like. So the first plot over there is on the x-axis we have the well flow rate, and on the y-axis we have production cost of hydrogen. So we can see that for natural hydrogen to be about $1 a kg, we need a flow rate of 75 kg per hour, and for stimulated hydrogen it is in the ballpark number of 150 kg per hour. And below that, the important thing is that below that the costs increase exponentially. So this tells us how important these two parameters are for any hydrogen well to be economical. And similarly for stimulated hydrogen, of course, since stimulated hydrogen has more upfront capex costs associated with it, the well flow rates and hydrogen purity that we will need from these wells will be much higher. And here we would need around 40 to 45% pure hydrogen, and for stimulated hydrogen that's much higher, which is around 70%. So this is hydrogen concentration in the well flow, hydrogen purity versus production costs. So this is the study that we conducted, and to summarize all of our findings, the geological hydrogen came out about 54 cents per kg, and stimulated hydrogen came out about 92 cents per kg. But given that iron-rich rocks are more ubiquitous and easier to find than hydrogen reservoirs, both would be cost competitive, and because transportation is also very important, and maybe the operations for stimulated hydrogen can be co-located with the end user, so that would reduce transportation costs significantly. And flow rates and hydrogen purity are the most important factors driving economics of the hydrogen wells. And below certain purity levels and flow rates, cost to produce hydrogen increases exponentially. And there are certain things which are a way forward for the study, which we can include over here. We can be more rigorous about the GNG costs involved and the cost to drill those wells. So currently we have taken the cost of the wells, drilling wells, we have taken at around 2,000 meter depth, but we can be more rigorous about that. And then, of course, we need more data on production flow rates to make these models more sensible. And then most importantly, we also need to understand the cost to the environment and possible mitigation strategies, because although it is low carbon, it's not zero carbon, so we need to factor in that parameter as well. And finally, in literature, we have also seen that injecting CO2 into these wells also accelerates serpentinization, and then we can permanently store CO2 as well. And we have some production, and we have some tax credits in the United States, 45Q tax credits for that. So including that into the analysis might also make these wells more economical. So thank you for your attention, and some of the people present in the audience also provided some inputs for the study, so I really thank them. Thank you.
We'll see if, okay. So thank you. That was a very exciting talk. We're going to just take one or two questions for the talk that we just had, and then we'll introduce the rest of the panelists. So is there anyone in the audience with questions about those details of the TEA?
Thank you for the talk. Bertrand Bello, City in France. Do you think the 200 kilogram per hour estimation of flow is realistic with what it's done, what we have today? Because you talk about 6 kilogram per hour in Mali, and as I understood, it's one of the main criteria for the economy of the system. So, is it realistic as a potential flow?
The simple answer is I don't know, because we do not have enough data, and I think we would need more production flow rate data from the demonstrations that has been happening throughout the world. So as of now, what we can do best is take estimates or take proxy from other similar kinds of industries, and natural gas is the closest analog. So that's what we have done over here. But again, in the Mali case, the purity is very high, so that's maybe a one-off scenario. So we also have to take that into account. But yeah, the simple answer is I don't know. Yeah.
Thank you.
So with that, I will have you sit. And then Olivier has 2 slides, and after that, it will be a conversation and presentation without slides. So Olivier.
Yes. Olivier Joubert, so I'm professor at Nantes University. I'm not coming from European Commission, I'm not coming from the National Foundation, so I'm not an expert in fundings. But I'm a simple researcher. I'm not also an expert in natural hydrogen. My research deals with ceramic materials for electrolysis or fuel cells applications. But I want to show you 2 slides about what I used to get some money from different origins. I will speak about France, because in France we have a national foundation called ANR, French National Research Agency. And in this agency we have different instruments. So we have every year a call. And if you are a young researcher, for example, a young researcher coming from CNRS or everywhere in France. So if you are a young researcher, you can have some money for 3 years to have, for example, one PhD or a postdoc to work with you in order to have some results. And if you want to have also some money with other colleagues from your lab or from other labs, doing like a consortia, you can have some money from, I will say, a collaborative research project, PRC. And if you have also one company inside this consortium, you can have money from the collaborative research project enterprise, PRCE. And if you have some collaborators coming from outside, there are some also international collaborative research project, for example, with Italy, with Germany, I don't know exactly, a large number of countries. So this call is every year in France. You have some money for 3 or 4 years the project, and you have about depends if you are alone or if you are a consortium. So you can have 200 to 800 or more euro for the duration of the project. So this is very, very fine for us in France. And there is also in France, there is a French National Hydrogen Strategy. This is, as you can see, a 10 years research project. In France, in 2020, the government said that we will put a large amount of money, 9 billions of euros, in order to develop, to accelerate the production of hydrogen, mainly electrolysis. Starting from a few megawatts of electrolysis, we will reach 6.5 gigawatt of electrolysis in 2030. And to do that, we have to have some gigafactories to produce electrolyzers. So we have to work also on this type of electrolyzers, alkaline, etc. And to support the research, there are 80 millions, nearly 90 millions of euros for 10 years in a priority research program and equipment on hydrogen. And in this program, we have funded 21 projects dealing from low TRL to TRL4 and dealing with production, storage and transport, utilization, system, and also a cross-cutting project. So this is for the national level, what kind of fundings we can have, and then we have also the possibility to apply to European level. I will. This is not. There are not all the. Yeah, it's okay. Just to emphasize 3 types of projects. The first one is coming from the Clean Hydrogen Partnership. I think that you know this type of project if you are in France, in Italy, or in Spain. We are using to apply to this type of project. So every year there is a call. I think the next call will be open in 2 months from mid-January and to mid-April 2025. And every year there are about 100 to 300 million of euros for this call, and typically there is a large number of tenders, and there is one. I know that there is one about natural hydrogen in the next call, but I cannot say everything on it. But just if you can see, there are 4 pillars. On these 4 pillars, there are many possibilities to apply and to get some money for a consortium. But first of all, you need to be if you want to know everything, you need to be part of the Hydrogen Europe Research Association, and this is like a research community, and we have a large number of members. And when you are members of that, you can have the details of the draft or the opportunity to write also some draft. The second possibility is coming from Horizon Europe, and I think this is like an additional funding to the Clean Hydrogen GU. For example, there are some possibility for having some Pathfinder challenge or open Pathfinder, but I think that Pathfinder challenge is more about biotech and IA, so I don't think it is about hydrogen. Open can be used, but you need to have some radically new technology to offer on this project. There is another one for the mobility, which is called Marie Curie. Marie Curie is well known also, Marie Curie grant actions. Don't hesitate to go to this website to have some more details on Horizon Europe. And the last one is Interreg. Interreg means inter-region, as you can see here. There are 2 types of Interreg program. One is North Sea. As you can see, this is the, I think it is the yellow or orange countries. Now this is blue. And this is also, there is another one which is called New European West, I think. And both of these type of Interreg programs you can have some money, but take care, you need to have some co-financial project. And the next deadline for this type of call is the next January or March 2025. But this is just 2 slides to introduce our discussion. But I think there are also some other possibilities for international cooperation.
Hello, good afternoon, and thank you for being here at this time after lunch. So my name is Carmen Font. I'm the CEO of Font Corporation. So basically, we are a boutique firm leading investments and expansions of non-Europeans, but also European companies in Europe, in the European Union. So basically supporting all the efforts in finding partnerships, scaling up the projects, and also joint ventures, and obviously accessing public funding and also private funding. Okay, so we are here today because we have the opportunity to join the private investment roundtable following to this one. But I really believe that we really have to work together towards having specific calls and a specific funding for the research in natural hydrogen, and also for investments and basically bringing into commercial phase natural hydrogen. So that's really important. And obviously not just in Europe, globally in the States and in all the countries that are adopting the regulation and want to support companies. We want to de-risk projects. This is key. So one of the really key elements to de-risk the project is to have the European Commission funding a project, or have the European Energy, the American Energy Department, the Department of Energy of the United States funding a project, or no matter where is the country. So public funding can really de-risk projects. So it's not about the money itself. It's not about the money. It's about who is behind this. So I think this is, as an introduction, enough from our side. So please feel free to come and visit us. We are in part of the exhibition room, and pleased to continue the discussions. And now I'm going to hand over to the questions. No? Oh yeah.
Yes. All right. I think most have been said by my colleague on my left, my French colleagues. But just a couple of notes, because I'm here as a user of funding, European funding. Here in Naples, we have been the last 3 years very successful. And of course, on the topics which feels more easy to sell to European community, but there is a couple interesting aspects on that side. The clean hydrogen partnership require people which are influential and help them to decide which can be the next call. Some of the call, I'm speaking on my side, that were on the hydrogen storage, is because there was a wave of people which were interested since several years to trigger the interest into the both research excellence, but also the clean hydrogen partnership. In 2024, there was a big call in which a lot of money went to various aspects of hydrogen storage, and we decided to set up several calls which were related to both bio and geosciences. So we are part of a project which name is Hydro, which is going to be soon starting, and there are several small companies which are inside, and the good thing is that that's money available to the company as well. If they want to add budget, they can add budget, but otherwise they can have the chance to get a laboratory to do science on specific topics that they may be interested on, proof of concept, on if you want to help develop technology or standard which may help to develop the technology. And the same apply to the research excellence. I mean, there are ERC which are more, I would say, nominal big project, which does mean you have to produce a proper, I would say, science topics aspect. But other aspect like the Marie Curie, for example, integrated doctoral networks. In our case, we had again another project which topics was hydrogen across porous media, and they managed to fund 10 PhD students looking at different aspects, which permeability, seal, but also modeling, mathematical modeling, and also various type of aspects were basically taken into account. Again, the crucial part is to have a good groups, which is mixing small company, big company, university, center, with a clear idea to do a training of research scientists, which will be the future user. The reason why we are stressing with the European project is that not all the countries are that rich like the French one. So I would say in Italy, we don't have that much money, national money available. There are coal within the Italian energy ministry, but they are not comparable to what France has obtained. So the only way for a lot of countries like that is to use that availability of European project, but that requires to prepare with company a kind of idea, so which are the strategy, the technology that we would like to develop, the science we would like to basically try to understand in order to prepare a kind of project which can be of both scientific, but also like a proof of concept for some technology. And I think there is a great opportunity here because European community has a lot of money. It's just about trying to submit the proposal. Sometimes the first time it doesn't go through, but the second time it may go through. And you start to build up in the same times this kind of strategy. A final word, there is another option which we discovered recently, but it exists in Europe since a while. It's called the cost action. Cost action is a very interesting opportunity because they are funding money to create workshop, exchange in a topics. And right now we submitted, we will see how it goes, a cost action looking at natural hydrogen in all aspects. And the cost action is a very good, I would say, triggerer of idea because you create workshop, they fund you ticket to travel, to organize workshop, and to speak about potential science, to speak about potential idea, to develop spin-off, etc. That's often is the starting point to try to integrate science from the different point of view. I mean, the interesting things in this conference that we have seen the part of the geosciences, of geophysics, of biology, probably maybe it's the time to integrate those aspects, and those are good opportunity where to discuss and develop those kind of idea. And it's open to company as well.
Wonderful, thank you. So we would very much welcome questions from the audience for all of the panelists. One of the beautiful things about this meeting is how international it is, and we also have online participants as well as the 400 of us gathered here. So online, last year's meeting was in Perth, Australia. We have a participant from CSIRO or CSIRO in Australia, and their question is just trying to understand of these funding schemes that were discussed so far. Are they essentially for European research entities, or are they specific grants or mechanisms for broader international collaboration? And that could be, again, to South America or to Australia, US.
I think it's important to, all what we've seen here is mostly European, it's European basically. So that's why I'm saying that we really need to work higher level even. So we just learned yesterday I learned from one of the American delegates that there are conversations going on right now between the European Commission and the Department of Energy concerning the schemes that have been implemented in the States in terms of regulation, in terms of funding for helping research and also potential investors and investments. So this is happening now. So this is great news for all of us. So what we've seen here is more European, and indeed, coming back to David, I think it's indeed very, very important to make the difference between research and investments again, because what we've seen so far is like more the research phase being covered or looking for a specific call for research. And we have been in contact from our company like all these years with the European Commission, and we know that Clean Hydrogen Partnership is going to launch this January a call for Horizon, call for natural hydrogen. So it's again good news. But again, what we look for is also the risking projects, and I mean the capex of the projects we are talking about. Just an appraisal well is 15 million, 20 million. So it's really very high cost. Okay, so we are talking about production cost of 900 million if we are trying to look for helium-2. So this is really massive figures. Okay, so the public funding is super required because again, it will de-risk projects that are could be if they worked. They really have very high IRR. So we are talking about a return on investment of over 50%, which is incredible for investors. So it's very, very attractive. But a way to have much more investors in this field is definitely having the public support and the public administration since the beginning working in specific schemes. And we've been working precisely on that. We are working on that. So just to wrap up, we've submitted 14th of November, so very few days ago, a call for the European Commission, specifically for investments and sort of building capacities in natural hydrogen. So we'll see what happened in this spring. So if we are awarded, we will be indeed the first European project being funded basically in the natural hydrogen field. So we shall see. So basically moving forward, no?
Wonderful, thank you. So comments or questions from those that are gathered about this area of how to finance? In the back.
Hello, Carmen. It's Owen, H2O. So I just wanted to clarify. I mean, I think, and perhaps my thinking has always been that government funding, grants are always, particularly around academic and particularly around research, technology. Are you saying and are you seeing that government grants might go towards drilling wells and actually doing sort of risky activities? And then who owns the well? Who owns the resources? How does that get sorted out?
Thank you very much, Owen, for the question. Indeed, they are very, very little, but there are some. So one particular coming from the European Innovation Council, SMEs agency, executive agency. So these calls are for building capacities, and then there is a higher strand for investments too. So we are talking about the risking investments and in what could be from the European Commission quoting. Well, if the public funding should be used for something, it should be precisely for natural hydrogen, because it's risky and we need to de-risk it in order to have investments moving forward and projects being really at commercial phase. So they agree that is needed. So there is a call, particularly call that where we might fit. This is the one I'm talking about, where we submitted very recently. And indeed, the higher strand where there are more money in it, it will cover precisely investment projects. So investment projects meaning drilling wells, or meaning putting a production phase on a stage within the European Union scheme. And I believe it could be open perhaps to sort of international cooperation with key projects worldwide. So this is something that it's open and it could be potentially be included.
While the microphone's coming over to here, David. David. Now the microphone, say I just entertained us, okay.
Thank you, David. Hi, Nicholas Pure from Till Capital. There's one entity or a group of entity that seems strangely, you just mentioned it, but strangely absent from the debate. It's the oil and gas companies. We're talking about risks, and here we're talking about public funding of de-risking. In 2022, okay, sources vary, but roughly, let's say that oil and gas companies took home, I'm talking NOx and IOCs, took home $800 billion only in 2022 of free cash flows. And we're here talking, you know, budgets of 2 billion there, 9 billion there, etc. These guys, they are the one who have the knowledge. They are the one who have the balance sheet. They are the one who know how the equipments work. And they wouldn't be the ideal people to actually fund and de-risk all of that?
Yeah, definitely. But what we've seen, I mean, the ones that are developing projects that are here, what we've seen here is like those companies are watching still. They don't jump into the projects, right? The large ones, the ones, the BPs, the Shells, the Cepsas, the Repsols, they are watching, right? So the point is like, if the European Commission fund a project, back up natural hydrogen officially and said, we want this to move forward, we back up this project with a few amount. It's not about the money, what I said, it's about who is behind it. So it's a clear guidance from the European Commission or the Department of the United States or another part of the world, another administration saying we want to back up natural hydrogen, we want to back up projects, we want to have natural hydrogen at commercial scale, it will incentivize the larger players and the key companies that we want to jump into the projects because they are very high capex. Indeed, it's very, very costly projects and they have the experience. I totally agree with you. They have to be involved. So they will be more encouraged, and not just them, other investors, you know. So it's like they will be more attracted to natural hydrogen projects from who is behind those projects, public administration facilitating in all the phases, no? Obviously financing, but also the permitting and everything. So it's sort of the whole thing behind a project. When you develop a project, who is behind this? Okay? Yes, I agree with you, basically, so.
Yeah, on that things, I think there will be a next round table later with private funding, so we will continue to discuss properly. But again, my word on that is that we have to try to understand ourselves, because if for the big company hydrogen is still something that it requires a proof of concept, and therefore they are looking at from waiting to see if there are basically the idea is working or not. The only way we have to go as basically researchers, as scientists, is to the right funding which are supporting proof of concept, which is research coal. Now, some of the coal are probably not hundreds of millions, but with a good laboratory, with 3 to 5 million of euro, you can start to build up a lot of good research. And well, that's in Europe, a lot of science has been growing up in different domains with this kind of scheme. So it's trying to fill all the gap, which help us to reconnect with the industry at the stage where they are still skeptical and waiting for the time being where they are at a certain point decided to jump on it.
Yeah, just to add, coming back to what David is saying, that scale up. So there are specific calls that aims to scale up. Scale up, meaning that they just know one pilot project. They want, like, obviously multiple pilot projects being developed. And also, what is going to be the next step? So being sure that your project is within a pipeline of projects in your company. So they want to see volumes. So this is coming. So indeed, because just in Europe, we have the 10 million tons hydrogen production by 2030, 10 million tons of hydrogen imports by 2030. So this is next door, right? Yeah, and it's very ambitious. So question mark, we will be there or not. So we shall see. So definitely natural hydrogen could contribute to not 2030, but probably the next decade, to see really volumes at the scale in Europe and beyond, obviously in other places worldwide.
So we have time for one last question and comment over here that's connected to this. Thanks.
Allegra Helsfordshire, I'm a consultant. Totally agree with you, Carmen. I just hope it's faster than that, than the 2030s. One source of public money we're not talking about is the public itself. So there are publicly listed companies here at this conference. So Hytera and Gold Hydrogen, they're traded on the Australian market. QIMC in Quebec, they're also traded. These are stocks that trade for less than $1, so it's fairly easy financially for investors to get in, but it's also hard for investors to invest in penny stocks. It can take several days for those transactions to go through. So publicly funded companies, publicly traded companies is another source of money.
Well, thank you to all the speakers for their contributions, and we do have a second panel that follows this that expands upon these themes. So if we could give them a round of applause, thank you. Yep.